Hello guys, welcome to my channel The Consistent Coder. So the problem that we are going to solve today is container with most water. You are given an integer array height of length n, and then there are n vertical lines such that the two endpoints of the ith line are I0 and I8 height at I. So basically you are given a vertical line, and then the height, the coordinates here are I comma 0, and then whatever the height that is being given at this point. And then you have to find two lines that together with the x-axis form a container such that the container contains the most water. So basically these are the different line heights that you have, and then you have to find two such lines. In this case, the second line and the last line. If you try to pour water in this container, you will have the most amount of water that you can store, as the maximum amount of water that you can store in this container. So let's try to understand this a little bit more. So these are the different heights, right? Now, if I select this particular first line and the last line, the heights that I'm going to have are 1 and 7. So if I try to fill water in this type of container where the left height is 1 and the right height is 7, I can only fill up to 1, right? So because even if I try to add more amount of water, the water would just overflow. That means I cannot store the water more than the height 1. So in this case, the area would be what? The width, which is going to be 8 in this case, and the height, which is going to be 1. So the maximum amount of water that I can store in this case is 8 area. And now there are different possible cases, right? Now I am not limited to choosing the first and last line. I can choose the second line whose height is 8, and then the third line from the last. I can choose this line as well. If I choose these two lines, I can store the water until the level height 8, and then the width in this case is 1 2 3 4 5, and the height is going to be 8. So that means 8 times 5 is 40. So height times width. So in this case, I have an area of 40. Let's see if there is any other possible case where we can get more amount of area. So let's look at this example where we have the height 8 and then I'm taking the height 7. So in this case, what is the water that I can store? So this is the amount of water that I can store, right? So this is the area that I can store my water in. So in this case, what would be the width? The width is 7, and the height, what should I consider? The minimum of these two heights, right? Because if I select 8, that what does it mean? That it means that I can store water to height of 8, but that is not the case, right? Once we fill this container until the height 7, after that, even if we try to add more amount of water, the water would just overflow, which is not what we want. We wanted to have a container where we can store the maximum amount of water in, right? In this case, so it will be 7 times n, which is going to be 49, which is the highest. So even if you take any other combination of two different lines, we cannot get more amount of area than 49. Hence the answer is 49 in this case. Let's see how we can solve this. The question says it wants the maximum area. How can we get the maximum area? Maximum area is width times height. So if we want to get the maximum area, we try to maximize the width and height. So what is the maximum width that I can get in this possible case? By selecting the two vertical lines that are at the extreme ends. So I got the maximum width, sounds good. The width is going to be 8 in this case. Now what is the maximum height I can pour my water here? It is going to be 1, because it is the minimum of these two values, right? Even if I try to add more water in this container, it will just overflow, because the minimum height is only 1, right? So which is going to be 8 times 1, the area is going to be 8. Now what do I need to do? I need to explore other possibilities, because I have already explored this possibility. Now I have an option to either move the left vertical line to the right side. What I mean by this, let's call this pointers instead of vertical lines. Now I have a chance to move this here to this, or I have a chance to move this here. Let's say I decided to move the vertical line that I'm choosing to the right side to the left side. So here I have 3. So in this case, what's happening is I selected the line 3. So the area that I can store my water in this case will be this. So the height is still 1, and then the width is 7. So the area that I'm going to get is 7. So that means the 7 is actually less than what we have received in the previous case. Now if you make an observation here, even if there was 12 in this case, the height was 12 of this particular line instead of 3. So even in that case, are we suggesting, are we improving anything in our algorithm? Because the height here is 1, right? Now it doesn't matter how long this vertical line is, because the minimum height is what is going to be mattering, is what is going to matter when we calculate the area, right? So even if it's 12, 25 or 100, it doesn't matter, because the minimum height is 1 here. So the height that we are considering is 1 times whatever the width is, right? So we are not benefiting from the fact that we have a higher height here. So instead of moving the j pointer to the left side, we should move the I pointer to the right side, right? I hope that does make sense to you, why we are moving the left pointer instead of right pointer. See, here we have the height 1, here we have the height 7. It would be more beneficial for us to move the pointer which has the lowest height, so that we can find a larger vertical line when we are moving towards it, so that we can find more height even though we are decreasing our width, right? So now I have moved my I pointer to this. So in this case, what is the maximum amount of area that I can get? The width is going to be 7 and the height is going to be 7 as well, because now what's happening is the minimum height we are considering is between these two vertical lines, the line 8 and then the line height 7. So the maximum area that I can get in this case is going to be 49, right? So now again we do the same analysis. What is the line that has the minimum height? So this is the line that has the minimum height. So what do? I move this pointer to here. So let's call this j pointer, and now the j pointer is going here. So now I have this height at 3. Now what is the maximum amount of water that we can store here? So that would be this. This would be the amount of water that I can store, correct? Because the water cannot go over 3, because otherwise it would overflow. So in this case, what is the maximum amount of area that I can get? So it would be what will be the width? 1 2 3 4 5 6 times, and then the what is the height we can get? 3, which is going to be 18, which is less than 49. So now what do? Now we see what is the minimum height of these two, right? These two pointers. Now again, 3 is smallest, so we try to move the j pointer to left side, so that we hope that we could get a vertical line of length which is greater than 3, which in this case we actually did. So in this case, what is the maximum amount of area that I can get? It is going to be the width times height, which is going to be 8 times 40. 8 times 5, which is 40. So which is also less than the maximum width that we have. Now again we have the same heights, right? Here we have the same heights, 8 and 8. Now we can decide to do anything else. I mean, I can either move my I pointer to the right side, or I can move my j pointer to the left side. Let's say I decided to move my I pointer to the right side. So my j pointer is here, my I pointer is here, the height is going to be 6 here. So similarly, we do this repetitively, and then we can get whatever the maximum amount of area that we can get. Hope you understood what is it that I'm trying to get here. So let's get into the coding part. So initially we have 2 pointers. The first one is going to be at the starting vertical line, and the second one is going to be at the last vertical line. And our condition is that whatever the left line is, it is always going to be to the left, and the right one is always going to be the right side. So my I is always going to be less than j. And now what am I going to do? I'm going to calculate my maximum area. So let's initialize the variable maximum area. Let's keep it 0. And then what will be my maximum area? It will either be the existing value that I already have, or width, which is going to be j minus I times height. So if we are considering, say, suppose these two vertical lines, the first one and the last one, how did we calculate the height? We calculated by taking the minimum of these, because even if we try to add more amount of water, the water is overflowing, right? So we need to consider the area which is exactly equal to the amount of water that we can store. So that would be, height would be minimum of the whatever the height that is at the left vertical line, and height at the right vertical line. Whatever is the minimum of those, we'll take those lines. And now how do I move my I pointer or j pointer? If my height at the left vertical line is actually less than or equal to height at the right vertical line, so in this case I'll move my I pointer. So since in this case my height at left pointer is actually less than right pointer, right? So I'll try to increase my I pointer in the hopes that I can actually get a height that is greater than this value, right? So it would be more beneficial for me that way. If this is not the case, I'll just move my j pointer by decreasing the j value, and then finally I'll return whatever the maximum area that I will have here. And also we have to make sure that this is in brackets, and let's see if this is working fine. Yeah, as you can see, this is fairly running good as well, because the runtime complexity is O of n. Hope you guys like the video. If you did, give me a like, and if you have any questions or queries, please do comment, and I'll be uploading on a weekly basis questions that are related to Blind 75. So if you wanted to receive updates, please do consider subscribing, and have a great day.